How's it going, everybody? This is another video on the Intermediate React version 5, a course taught by Brian Holtz, a software engineer that has previously worked at Microsoft, Reddit, Netflix, and currently he is working in the VP of products at SQLite Cloud. That to me is something interesting, and I very grateful and humble to learn from his experience and their pain points. So the entire course is just a way to learn how to write production ready React applications, right? And in this course, its focus is on tools and techniques that allow you to do that. So techniques or advanced techniques like the code splitting, the server-side rendering, the testing and transitions, okay, and tools that allow you to do that. For example, Redux, Tailwinds, and TypeScript. So it is quite simple, okay. And so far today, I'm gonna focus is on the advanced React performance, okay. So far we have looked at hooks in depth, which is great. So for example, like use ref, use callback and memo, use reducer, layout and ID. And then we jump to Tailwinds to understand what Tailwinds is, what is the difference between Bootstrap and material design from Tailwinds. How can we make use of Tailwind? What is the anatomy of Tailwinds? How can we extend Tailwinds? And how we can play with layout with Tailwinds in a much more easy way to do that. And finally, here is the advanced React performance. Again, code splitting and server-side rendering. So that's what we're gonna look today. Here, this particularly techniques. So for example, code splitting, the value proposition of that is that you want to let your user, you want to let the user experience be fast, so you can now turn your customers or you can turn your visitors into customers. So by offering is a great user experience and retain the retentions, the user retentions, as well as converting user conversion. So now we will able to actually close a sale, which is, after all, that's exactly what we want here. And that's the reason why we are developing this kind of application. We want to offer is a product to a user out there in the internet that might use or might be useful for them. So improving the user experience and now lead them to finally close the sale. So user retention and user conversions. So now we can develop is our business and, well, improve on that. So because of that, code splitting, what it's trying to do, or the value proposition of code splitting is that. So how can we do that, right? Because code splitting, after all, especially if you want to now set a particular limit or a target to reach, okay, or you might want is to define is not only a performance timing to reach, but also a metric to stay under that. So because of that, all right, you need to have a performance budget or some sort of way to actually measure that. Now, how you can do that in React? Glad you asked. It's actually expose React is a nice convenient feature called lazy. I don't think we added that. There you got it, lazy. So if we take a look at here, this, okay, this is something that we tell to React, hey, this particular component, React component, we're gonna defer them, we're gonna delay them. Okay, I don't want you to load them on the initial page. So this is how we can tell them, and what will happen when something needs to be loaded somewhere in the future, or when we have to we need to find a way to show something to the user while loading that, and that's what we use suspend component. Okay, for example, in this case, hey, you're gonna show this fallback uh, until suspends return. All right, so that's great. It actually enable and open my mind to say, hey, this is what we can do. How can we do? And there's a couple questions here. The thing is that how does React know which component it needs to defer the loading, or which component needs to load once you, for example, define is a route, or when the user navigate to that particular route? That's one. And the other is, all right, yeah, that's one. That how React does that. Okay, the how React actually is tracking, or what is the mechanism, how React does that. And the other is, well, let's go step by step. Okay, let's go step by step here. Okay, first is this, and this is how React does it do this. Right? How React is actually behind the scenes is deferring or keep tracking of this. How is this possible? Well, there is something called service worker that allows you to run tasks in the background. This is something that it will change your architecture, the architecture of your application. Okay. Another question is that, okay, so if this is something that is handled by service worker, can we be optimistic about it? Or can we load stuff in the background? The answer is yes. We can load these things in the background, but we're adding is this factor of complexity here. As I mentioned before, it will change the architecture. Okay, so this is the best way of how you can is defer or run this task in the background. Okay, so what are service workers? You might wonder. Well, they sit between the the app request and your API to decide, hey, once your app is loaded and the service worker is loaded, okay, now you can detect if this particular React component is being loaded. If it is, there is no need to do a new request to the server. So code splitting is this particular strategy that actually splitting all of your code. Okay, they use a hash to do that. That's something that React does. Okay, it hashing all of this code splitting, or all of this little piece of codes, and then the way how you can now run this task in the background. So, for example, to say, hey, do we have this resource? If this resource is available, do we catch this resource? All right, instead to actually do a round trip, go again, hit the server and going back. So instead of doing that, it's like, okay, how can we do that? How can we improve that? Service worker is the way to do this. Service worker, after all, it works is on another callback queue, but again, this allows you to do this different. This allows you to do is different, or this run thing in the background. And while doing that, you can think of this, which is pretty much like set timeout, the callback queue, right? The callback queue or the job queue, which is when promises are added and removed. So service worker is, or I'm assuming that is using is another queue here. Again, something that I would like to dive deep. This might go beyond the scope of this section, but the idea here is that service worker allows you to run this task in the background, especially when we need to know if we already fetched this resource, so we don't have to fetch that again. All right. So you might wonder, is like, okay, but how service worker works? How do you do that with service worker? Because we're using is now Vite or any model bundlers, Vite, parcel, that kind of thing. You will end up doing is letting the model bundler to generate a manifest where it can contains all of these configuration files that it needs to service worker to say, all right, now I know what will be the resource that we will need to fetch. So service worker is not only allow you to work with this it's not only allow you to work with this service, is not only to allow you to work with offline applications, which is something great, okay, and also allow you to do some push notification and features that are making these web applications unstoppable, okay. And I think that any moment of crisis, there is a huge amount of innovations as well as a huge amount of Ponzi scheme. But in this time when we talk about this innovation, PW might be a factor of where people are going to use this. But in any case, so that's what it is, the service worker, how service worker fit here on this puzzle, on the code splitting puzzle, okay. So Remix is actually a framework that is kind of do that for you, but you can do that for yourself. It is a course of PW service worker and deep dive with deep dive service worker with Kyle Simpson. Again, this is something that companies were looking for, guarantee, especially for e-commerce. Okay, so the e-commerce industry or the field service management, these companies here, or the companies on those industry, they need to offer is offline capability to the users, and also having sync with that. While guarantee the correctness of the applications as well as push notifications, among other features that are needed here. So yeah, and as with any technology, there is a trade-off. So now that we look that particular, and then now that I understand that particular feature of code splitting and how that fit in our React application, okay, as well as service worker, now it's time to look at another technique, which is the server-side rendering. Server-side rendering pipelines or these node streams, and then is the server data fetching, okay. So that was interesting because with server-side rendering, the promise here is that we don't want to send is this bare HTML to the user. Okay. In fact, we want us to render is an entire applications so the users can see what we're loading while letting the web crawler rank them properly. Okay, so what server side is gonna do is reduce the size of the initial rendering page. Okay, that's what it does, this server side rendering. So reduce the size of the initial page load, but increase the time of interactivity. So the idea here is that yeah, completely. That's exactly what server-side rendering is doing, uh, or what this server-side rendering is going to do. Pretty much like a single-page application, where you can now show is the so we can give the time the users to look at the page and understand that, and by the time it does that, by the time it do that, let loading things in the background. Okay, so load all the things necessary in the background. So that's quite interesting, bro. That's very, 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 holy moly, very interesting, bro. Completely, bro. Mm-hmm. 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 Totally, bro. Totally. What? Yeah, totally. Totally. Mm-hmm. Mm-hmm. Okay. So what we're gonna do here, okay, is to create. The idea here is to avoid user frustration when navigating your app and bounce it. Okay, but that's the whole idea of this server-side rendering. Is okay. We need is to rend. We don't want to show is the bare HTML. In fact, we want to show the user content, and by the time you understand that, in the meantime, loading all of these things in the background. Okay. So the idea here is that avoid the user frustration when navigating our app. That's what we are doing with this called thin hydratate. That's what it called hydratation. It's like we're gonna send the necessary content that the user can see that, and in the meantime, while the user is understanding the website, now we're loading all of the things in the background. So we're adding is styles and animations and that kind of other things, analytics and things like that. That's something very, very, very interesting. So this is what it is. Now what it does is this. There you got it. We already create that? Oh, no. Okay. So the thing here, let me actually take a look at that course. Mamá huevo, ¿por qué me quieres eso? Okay. Thanks.
So we're going to put all of the note or the browsery stuff here in client app.jsx. So first thing we're going to do is import hydrate root from React DOM/client. We're going to import browser router because it's in the name. You can't load browser router in Node, so that comes from React Router DOM. And then we're going to import app from app. Okay, root alert, because one, there's no window, and two, there's no alert. So you have to make sure that anything that interacts with the DOM is not loaded in Node, or else it breaks. So we're going to put all of the note or the browsery stuff here in client app.jsx. So first thing we're going to do is import hydrate root from React DOM/client. We're going to import browser router because it's in the name. You can't load browser router in
The server in Node.
Node. So that comes from React Router DOM. And then we're going to import app from app. Okay? And then here, we're just going to say hydrate root. We're going to tell it where to hydrate it. So document, get elements by ID, root. We're going to say browser router, app. And that's it. My notes there is incorrect, so that is it. So all we're doing is we're loading the app, we're loading browser router, we're doing everything that has to be done in the browser here in client app. Imagine if you had something like Google Analytics, you would do that here, right? Because you don't want to run analytics from the server, you want to run analytics from the browser, right? So anything like that, you're going to throw here in client app.jsx. Anything that's only going to happen in the browser and not going to happen on server-side renders. That goes here, okay? Go back to index.html. This is going to load client app, not app.jsx. So that's important. Okay, and then go to app.jsx. Get rid of browser router here. Don't load that. Delete that from your app here as well. Oh yeah, get rid of the React DOM import up here as well. Yes. So this one right here, the create root one, just get rid of that altogether. And then down here at the bottom, get rid of all this root.render stuff. And we're just going to say export default app.
Okay. So that makes a lot of sense here. That makes a lot of sense. Okay. There you got it. So we are here now. Let me actually write a little bit here about that. So we need to create two files. Okay. Those that will contain code relevant to the client, okay, to be rendered, because that's the whole point of this, and for the server, for Node. Okay, so this is called, actually you're not able to see what I'm doing, is this. Right now what I'm doing is just writing here. Okay, so this file, which is called the client, which is going to render all of the necessary code that matters on the client, the browser, okay? Again, remember that the entire reason of using this server-side rendering is to reduce the initial page load times while increasing the interactivity. That's nothing bad, but during this time, we're gonna load things in the background, okay? So we got is the client side, okay, the client app, called GSX, as well as the server app. We call this GSX. Okay, there you go. And this is something fairly common with a lot of applications out there doing that. So if we take a look now back to our code here, which is this, you got this, that's right. So here we're gonna is import, okay, import from the React DOM a library or a function called hydratate. But the thing is, hydratate function, I think is hydratate root, something like that. I think is that. Is deprecated? I'm not sure, but again, is a function where we want to hydratate this. Is hydratate root? Okay, hydratate root. So this function, as well as the router or React router, exactly, which is the browser. I think is browser here. For some reason, doesn't work for that. So browser router. I don't know. I don't know why it doesn't actually autocomplete that. Browser router. Okay. It's like browser router here. So this is, we're also going to import is that the main application. That's right. And you think you're funny? Okay. Please see my guess. Oh my God. Import. That's right. And here we're gonna say, hey, hydratate root. We want is the first parameter is to identify what is the element root that we need to hydratate, which is in our case is document dot get element by ID by root. Yeah, get element. No, stop. Get element. Exactly. Okay. I'm telling you, I want to do this. All right. And then we're going to pass this now the root render. So the actual content of here, or in this case, the render 3. With, of course, the browser router here, as well as the app. All right. And the browser render for that. So here we're going to tell on the client side, this is the content that you want to show. Okay, I want you to prepare everything here, but this is the content that you're going to show, and this is when you're going to is load things like analytics for that. That makes sense. So this is where you are. This is where you are going to load the This is where you're going to load the client side, the client code. For example, analytics. analytics, right? That's good. That's great. That's cool.
And client app. Imagine if you had something like Google Analytics, you would think that's only going to happen in the browser and not going to happen on server-side renders. That goes here, okay? Go back to index.html. This is going to load client app, not app.jsx. So that's important. Okay, and then go to app.jsx. Get rid of browser router here. Don't load that. Delete that from your app here as well.
Because we're going now to make this app general purpose.
Oh yeah, get rid of the React DOM import up here as well. Yes. So this one right here, the create root one, just get rid of that altogether. And then down here at the bottom, get rid of all this root.render stuff. And we're just going to say export default app.
The app, exactly.
So far, so good. So we're making app now general purpose that it can be run either in Node or in the browser.
So another important thing here, another important thing here is we have to make our app to be general, so we can import that in our browser and the server, or the server, exactly. So that's why we have this particular code in our case, which is, this is the client app. We make this app generally as possible. That now things are starting to make a lot of sense, like so. Okay, starting to actually look like applications, real life applications. Okay, export default app. That's right. So if you take a quick look at the jobs etiquette here, that's right, the job etiquettes. When you take a look at that, but they're using is now this. All right. So for example, in this kind of application, if you take a look at this, on the entry point, they must have some sort of app or entry app or things like that. When you have the page, exactly, this is the entry point of our application completely. And then you have is, for example, the auth provider, the client provider, theme provider, localization provider, and that kind of thing, right? App layout, those container, that kind of thing. Export default with LDP provider, and then you got it. And of course, because they're using is Next.js, it's like, hey, there's some couple abstractions here that we're doing for you, right? Yeah, there's a couple abstractions that we're doing for you. Matching path below to learn. Then you're doing this kind of thing. Interesting. And they also here they are using is SST for that. That makes a lot of sense. Functions, cron jobs, resource. Okay. Next environment here. Okay. Okay, and the SST config, exactly. This repo is using SST. Alright. Okay. That makes quite a lot of sense for this. Yep. Totally. Backstage for that. VS Go and the kind of thing. Alright. That's interesting. Yeah, that's interesting. Because now we abstract, so we make is the entry point of our application, the app, generally, so we can now deploy that on the client or on the server, but without crashing them. In other words, we're gonna use the proper libraries on the environment that they are running, on the browser or on the server. And on the browser, we want it to run is, for example, analytics, and on the server, we want it to run specific applications like loggers, for example. Okay, that makes a lot of sense.
Now we need a server app.jsx. So make another new file called server app.jsx. Okay, here we're going to say import render to pipeable stream.
Okay.
From React DOM/server. Import static router from React routers DOM/server. And import app from ./app. Okay, static router is basically React router that can be run in Node. That's all it is. So it's all the same machinations of like how to resolve routes, what route they're on, which one to send them to, navigation, all that kind of stuff. But it doesn't have all the stuff that ties into history, which is only in the browser, right? That's why we need static browser, not browser router. Render to pipeable stream is something that can only be run in Node. This is actually going to run our application, and it's going to run it into what's called a Node stream, right? Which is basically like this thing that it'll progressively render your app, and it'll give your app progressive output, so that when a user makes a request, we can slowly serve them pieces of information as they're available.
And there's a lot of things here is going on, especially when you define is the no, not here. Server.js, SSP, yes, this is one. Especially on the server, especially on the server app.js here. And that's pretty interesting because here we are doing is this. Look at what we are, I don't know if you can follow me along with it. Exactly. Look at the name of the function that we are importing the client, which is hydrate. Okay, let's go to hydrate. Whatever we are receiving, whatever data that we are going to receive here, I want you to now hydrate here. Pretty much like a tree, right? So when you're starting to pouring water, and then with the days, weeks, months, years, hydrate that. So this concept is called like that because now you are saying is that, hey, on the root of this entire 3 render, I'm gonna add this element, and I'm going to let you to render this. I want router, I want the React, okay, actually render this component for me. That makes a lot of sense. Okay. Mm-hmm. That makes a lot of sense. That makes a lot of sense. That makes a lot of sense. Exactly. That makes a lot of sense. This is on the client. And now on the server is going to look and say, hey, I'm going to now prepare is whatever I'm going to send that using is import from React, from the React DOM, assuming, or the React router. No, the React DOM is say pipeable stream. It's like render to pipeable stream. Oh, exactly. But it's React DOM slash. So React DOM server. What? Exactly. React DOM server. And here's where you're gonna say, hey, render to pipeable stream. And the other is import this. Import React from the React router DOM to say, give me the static browser, or a static router here. Exactly. It's a static router. Oh, but it's of course it's on the render. Okay, both of them are from the render. Would you say server? Exactly. And now here you say static router. That makes a lot of sense. So this kind of instruction here from the React DOM on the client, which is after all this is what this library is for the client, and the other is the React DOM server, is going to tell these different instructions that, remember, the end goal of this is to show something to the users, so reduce the initial page load times, and in the meantime, while the user is understanding the page, load everything in the background. That's the idea here. Load everything in the background here. That's cool. That's pretty cool, by the way. Totally. Totally. I think here we need to import is the app as well. So I'm assuming that. Yep. Because after all, this is at the two branch here. So we say, hey, this is going to be client. So whatever the target is the client, whatever we are loading content on the client, this is what you're going to do. Or whatever we are loading is content from the server, this is what you're going to do. Okay? In other words, is that if the client, it means that, hey, it's navigating on the client, it's navigating on the client there, or there are operations that only happens on the client, render this. If there are operations that only happens on, so for example, on analytics, render all of that. If there are instructions that it needs only on the server, render all of that.
Progressively render your app, and it'll give your app progressive output, so that when a user makes a request, we can slowly serve them pieces of information as they're available. the way that this used to work is we used to have to render the entire thing all at once and then send them complete HTML. Now with React Router, or sorry, not with React Router, but with React 18 and Suspense, we can send them piece by piece.
Exactly.
I guess it was React 17 that did that, but who's keeping track? Okay, we're going to export default a function called render, whatever you want to call it, URL and options. Okay, and then const stream equals render to pipeable stream. Static router. Location equals URL. And we have
the
app.
application. Exactly, static router.
And then we have ops. Ops, like that. Okay, and then down here we just return stream.
So there is a lot of things going on, totally. There is a lot of things going on, especially from this. All right. So now that we are on the server, we have to define a function. Instead of calling is server app, we can call is just render. Okay, that's interesting because you know, it has render. It has. This is something that how do you put it? GitHub Copilot has crawled to all of these different code bases and say, hey, this is it. It is what it is. Export default function render, where here we're going to receive is the URL. And look at what it's doing in the URL and the ops here. So because now, if you're going to also pass to context, is something important, and this is when things started to get quite fucking complicated here. Exactly. But the idea here is that you're saying is, okay, I'm going to create now a stream here from the server, okay, which is I want to render, when I call the function render to pipeable stream. It means that you're going to pass this chunks of data bit by bit, not like we did before where you pass you render the, so you wait. That's one of the reasons why a lot of people actually using NodeStream, because again, in the past we wait for the complete we block the main thread by running this by letting the server, hey, I want you to run this server, I want you to run this application. We block the main thread by calling the render function and wait for that to happen. Okay, so that might be great for small applications, but when you now have to serve over 10,000 clients, okay, then you want to you need a way to do things faster. So that's what we have with pipe, or in this case streams. Okay, you're gonna send chunks of data and won't block the main thread. Okay, interesting. Render to pipeable stream. In this case, here's where you're gonna pass what is going to be render. Okay, which is in our case is the static router, the location, and here is the URL that we're passing as parameter. Okay, so here we're saying, yeah, instead of using as the browser router, we're going to use this static router from the server, so you can handle things like what would you gonna do when match this URL, and in there do not use things like history, because that's only for the client. Okay, and then you're gonna render the app for that. So after that, we're gonna return is the stream. That to me is very, very interesting, bro. Very, very, very interesting. So there's a lot of things going on, by the way, here. Let me actually follow me along here quite a bit. Okay. And then we got is this. So render to pipeable stream. Okay. So render to pipeable stream is a function that now sends, which is according to him,
router. Render to pipeable stream is something that can only be run in Node. This is actually going to run our application, and it's going to run it into what's called a Node stream, right? Which is basically like this thing that it'll progressively render your app, and it'll give your app progressive output so that.
So render to pipeable stream is a function that use node stream, exactly, that use node streams to, exactly, it's a function in singular. It's a function that use node stream to render small chunks of output, because that is
when a user makes a request, we can slowly serve them pieces of information as they're available.
to render small chunk of output to be served as they are available. And I think this is something interesting of all of this string thing. Hey, I process this, I render this small chunk of this. Now I'm going to send that, all right, so the client can receive them as they're available. That's what it's doing, this render to pipeable stream. Renders to pipeable stream. Interesting. Completely interesting. Render to pipeable stream. That makes a lot of sense. Oh man. Yeah. Totally. Okay. Yeah, completely. Jesus. Oh my god. Okay, that's interesting, by the way, because here render to pipeable stream in this particular context is using node stream to render small chunk and to render small chunk of output, or to render small or to output small chunk of renders and make it available and send it. No, make it available to the client as they go, as they consume that.
The way that this used to work is we used to have to render the entire thing all at once.
So the way that this worked before is that now you have to render it. You have now to render fully.
So then send them complete HTML. When a user makes a request, we can slowly serve them pieces of information as they're available. The way that this used to work is we used to have to render the entire thing all at once and then send them.
The way this worked before is now the way this worked before is that you have to render it completely before it's sent, before it's sent.
Complete HTML.
Before it's sent. Exactly. The way this worked before is that you'll have to render it completely before you send it. This, of course, cause the main thread to block, do do massive inbound, or do sometimes massive incoming requests to process. To be processed. Okay. So the massive incoming request to be processed. Exactly. And this, of course, cause the main thread to block, sometimes massive incoming requests to be processed, especially in big applications. Okay. That's pretty fucked up.
Now with React Router, or sorry, not with React Router, but with React 18 and Suspense, we can send them piece by piece.
Exactly. Now with React Router, now with React 18 and Suspense, we can send them piece by piece, which is great.
I guess it was React 17 that did that, but who's keeping track? Okay, we're going to export default a function called render, whatever you want to call it, URL. Okay, and then down here we just return stream. Is we can now just render, we can just have vite build server app.jsx, and then we can import what is built by, now what's cool about this and this approach,
I need to, wait, what the flame fuck is this? Who create this? Anyway. Okay, now when we take a look at our code here, which is this, all right, exactly, you're gonna return this. Now we can tell, it's also change the client app.js, exactly, because this is only going to fetch this content that is on the client. The question is that how do you instruct now to the server to actually, well, do that? Now how you tell to your server, hey, this is the function that you need to load on the client, and this is the function that you need to, or this is what you need to render on the client. This is what you need to render when someone asks when a request hit the server.
I didn't used to do it this way. I think this is much more elegant than the way I used to teach this. Is we can now just render, we can just have vite build server app.jsx, and then we can import what is built by vite. Is we can now just render, we can just have vite build server app.jsx, and then we can import what is built by vite into Node. So we don't have to build our entire Node server. We just have to build server app, which then interfaces to our JSX, right? Because Node can't read JSX. That's the problem that we have here. Does that make sense?
Yeah.
So now we can say, hey, vite, build this for me, and then in our Node application, we can say import the built output.
Okay, because here is now, exactly, here now, vite is going to Okay, so Vite now is going to read our GSX file improperly because it's that.
Your alternative is using something like Babel node or something like that. It gets really janky pretty quickly. Okay, all that sounds good. Go into your package.json.
And we need to now build that to tell Vite, hey, I want you to build this.
We're going to go in here to your scripts and we're going to add a couple more. So we're going to have two different builds. Build server, which is going to be Vite build outdoor dist/server --ssr server app.jsx.
Completely. Makes a lot of sense. This is in this particular case.
And then when I have multiple build steps, I'll do something like, and to be super fair, this is not this. I don't think this works in Windows. Not teaching make today, or ever for that matter, but definitely not today. Okay. And then server, we're going to have just node server.js, something like that. Or start, not server, just node start. npm run start will do our node server.js. One thing that you do need to add to your package.json, please up here, just put type : module, because we're going to be doing modules in Node. It requires this type module for it to be okay with that. Okay, getting closer. Please npm install express at 4.18.2. You might ask me, like, why don't I just do this in Next.js? You probably should. I'm showing you how to basically build Next.js, right? I'm showing you what Next.js does under the hood for you.
Exactly. That's the whole point of it.
And then after this course, hopefully when you either take Scott's course or something like that, you'll really value what Next is doing for you, because this is not necessarily always that fun to do, right? But what's cool, what I'm showing you here, is that you don't have to use a framework that's React aware, right? We can build this in any node-based framework. So like when I worked at Netflix, we were working with Fastify, right? Or Fastify? Restify. Restify is the one that Netflix uses. This was the kind of stuff that we were doing there.
Okay, that makes a lot. Okay, now that's quite interesting, because it's like this. It's like,
all right, let's go write our node server. This
because all of this instruction was to indicate React to do the server-side render. Here now Vite is going to read our GSX files and properly import the components needed. So this step, what we did here, by now adding is this. We already fixed that. By now adding this, as well as the package JSON, this is when you say, hey, you know what? We would like to use the build client, and here I want to instruct to Vite or any model bundler that you have, Webpack, let's see, so Webpack, Parcel, right, Vite. You're gonna say, hey, I want you to build the projects, and please, I want you to now output this on the client, on this directory here. And the other is the server. Okay, hey, I want you to build is the server here by saying, hey Vite, now this time I want you to build is on this directory, okay, on the distribution server, but with server-side rendering, okay, but with server-side rendering flag. The server-side rendering flag, which is in our case the server app, okay. So all of this was just, okay, all of this was just to say, hey, I want you now to run the command build. And here, this is something that Brian Holtz actually do that anytime he have several commands to run. Oh, and then he says this: a Vite build, npm run build. Oh my God, build client, npm run build client in npm run build server here, and we add this as well as with this star here, which is with node experimental fetch and the server.js. That's quite interesting, by the way. All right. Okay. That's interesting, bro. It's very, very interesting. Then
It's going to be outside of source. So here in the root directory, write a server.js. We're going to be doing this in ES6 modules, which can be kind of a pain with Node, but it's fine. Import express from express. Import fs from fs. Import path from path. Bear with me, there's a decent amount of typing here. Import file URL to path from URL. And import render app from source slash, oh sorry, we actually need /dist /server app.js. Now,
exactly,
this doesn't exist yet, right? We need to build it, which is before we run the server, we have to run npm run build :server, and then we can run npm run start. But we can't import the JSX file directly. It has to be built. Okay, const dir name. Because we are in ESM modules with Node, dir name doesn't exist, which is a constant annoyance to me. So we're going to say path.dir name, file to URL path, import meta.url.
This is
a very weird thing, but basically,
yeah, this is a very weird thing, but basically what you're saying is that, hey, what is the file, what is the path of this file? So what is the path of the current file here?
basically, if you're used to writing Node, this is how you generate what was __ dir name before. If this is unfamiliar with you, just know that this dir name is now whatever directory we're in, right? So it's going to be, yeah, whatever directory in our project that we're in. Const port, this is the port we're going to listen in. Either process.env.port. This is just a convention for cloud computing. So if something passes in a port, we'll use that for our port. Otherwise, we'll use port 3001 by default.
Convention.
Const HTML equals.
Now we decide to render this.
fs.readFileSync.
So read that file which is on the render
path.resolve dir name and /dist/client index.html dot toString. So what this is going to do is our project is going to build out an HTML file. We're going to go read that HTML file because we need all the...
Exactly. Our project we're going to build, okay, this is what it's doing behind the scenes next. Our project is going to build is the client folder.
paths.
Exactly. Our
So what this is going to do
is the server.
is our project is going to build out an HTML file. We're going to go read that HTML file because we need all the paths in there, right? We need where the CSS is, where the JavaScript is, because they have like all these hashes attached to them. And so we don't know what they are in advance. So we have to do this part to go get the proper paths for all those different things. In other words, we can't just use the source file because it's not going to be client app.jsx at the end. It's going to be some...
Exactly, because it's going to be... Remember, the entire goal of doing this is to say, hey, I'm gonna build is the final output, which is on the client, the server. We want to build is the final output that is going to be
JavaScript.
Send that.
Okay. I'm going to split it into two parts because when a user makes a request, I'm going to give them the head first. So looking at my index.html again. When a user loads my page, immediately we can flush out to them all of this, right? Which is good because then they can start loading all the CSS. And spoiler alert, they actually move the JavaScript up here as well for you. Exactly. So they can start loading all the JavaScript, which is great, right? So while they're parsing all of this, they're loading all this stuff, and then we can be running all of our server-side rendering in the background. So multiple things are happening at once, so we're giving them the best experience that we possibly can. So that's why I'm splitting it. I'm just going to split it into parts. The first part, this part, and the second part, this part. So I can split it on what? Not rendered, right? Exactly. So I'm going to just literally split it on that. HTML.split.
This is something that Scott Moss actually mentioned. Okay.
Now, typically, I would imagine most people would probably do something like... That's probably a more robust way of doing it, but I'm lazy and I'm not going to do that. I'm just going to do not rendered because it's already there.
This is exactly what it's doing.
Okay.
A lot of these servers. A lot of these servers, what they're doing is behind the scenes is rendering that. I'm going to take this HTML stream, okay, and then I'm going to populate that with some dynamic data. And in this case, data that comes from our auto-generated build. Okay, and then send that. That's what 99.99% of all of these servers are doing behind the scenes is interpolation. They interpolate a stream, or they interpolate an HTML content with some dynamic data coming from the database, usually, or from any other data store, and then prepare that to be sent.
Now let's make a really basic Express app. If this is not familiar to you, it's totally fine. This is not an Express course.
No, but I get it.
App.use /assets express.static path.resolve. This is just serving all the static assets that we need to do. Dir name ./dist/client/assets. This will serve all of our images, our CSS, our JavaScript, all that stuff. Did I import Express up there? I did, right? Oh yeah, sorry. That's app equals Express.
And then you have the Express here.
Okay. And then here is the magic, what you've been waiting for. App.use. We're basically saying on anything that's not served by a static asset, let React handle, okay? Request and response.
Okay.
So what did I say? The very first thing is we're just going to flush to them the header. Res.write parts 0. immediately flush them all, everything that's in the head. Then const stream equals render app. Again, this is the app that we got here from dist server app.js.
Once we already built that, but this is the app.
Them all, everything that's in the. Just gonna.
But it must be from the
request
client.
Res, then dist server app.
Okay.
.js equals render app.
This render app should be is the final output.
Again, this is the app that we
exactly should be the final output from that. Yeah,
got
that
here
makes
from
sense,
dist
because
server
this is what is going to be
app.js.
sent to the client.
We're going to give it rec.url and this object of on shell ready stream.pipe res, okay, on shell error.
Okay, on the shell. Okay, when the shell is ready, pipe.
Do error handling here. This would be log it out to your error service, log it out to your, I don't know, whatever logging service you're using. I'm not going to do anything here because we're probably already taking too long on this anyway. So anyway, that's what on shell error you would do there. And then on already, this is basically everything has happened, so we're done. So this is the last thing to write. Res.write parts 1. So this basically means everything has been written out. Because remember, React is going to give it to you incrementally. It's going to give you one piece, and another piece, and another piece, and another piece. On already is basically, all right, everything is done now, right? So we're good to go. We can write the tail of it, and then we can close the request with res.end.
Okay, we can write the tail of this.
And then on error, like on an actual error, we can console log that out. Okay, so that's all of that. Lastly thing we'll say is console.log. Listening on http://localhost : port. I like to do this so then I can command click in my VS Code terminal and it'll take me directly there. And app.listen
Listen to the port.
Okay. So stream.pipe, this is the important thing here. Stream, we're getting back from a render to pipeable stream, which is a node data type streams. When we pipe this together, we're basically saying the response object and the React stream are being connected to each other. So the data type streams. When we pipe this together, we're basically saying the response object and the React stream are being connected to each other so that whatever is coming, when we pipe this together, we're basically saying the response object and the React stream are being connected to each other so that whatever is coming out of React is going straight to the user. That is exactly what this does right there. If you have more questions about stream data types, I'm pretty sure Scott's course has got to talk about it, so watch Scott's course on Node.js. There is one thing that you might consider doing if SEO is really important to you, which I imagine to many of you it is. Rendering things to stream can be a problem because to Google it looks like you're slow because it's worried about as a crawler getting everything all at once. So what you might do here is like, if it is the crawler, do nothing here, and then on already, which basically means everything is already. You'd say something like, if it is the crawler, then you would do this here. Because once you have the whole thing here on already, this would just dump everything all at once because everything would be ready, right? So it'll maintain that back pressure and then you can just dump it out all at once. General gist of how you would handle that. Okay, so let's make sure I'm not out of my mind. It's always a possibility. npm run, you want to run build client.
Exactly. First,
You can see here I got a bunch of stuff output there.
which is something that you're telling to Vid, hey, I want you to build is now this particular app. So Vid say, okay, what is this? It's a React application. Interesting. So let me now look at that particularly. Let me now look at the client here and say, hey, this is what we're going to build here for the client.
I'm going to do npm run build server. Got a bunch of stuff coming out here for the server assets. Cool. Run build.
Exactly. As you can see, it is doing on the client side is doing is all of this code splitting here.
Server. Got a bunch
And as you can see here, is doing that as well for the server.
of stuff coming out here for the server assets. Cool. And now I can say npm run start. And I have a server running on 3001. Might have an error? No?
No, because there's no route there.
There we go. I don't know what's going on there. So, one of my favorite things to do here is to look at the page source because that'll tell you what it's getting on first load. You can see now it's getting a bunch of this stuff on first page load, like all of the various different animals and the select and everything like that. But notice on the first load we're getting no pets found, right? That makes sense. It's not doing any AJAX on our server, right? It's just going to render out the very first thing. So if I refresh here, notice that we get no pets found immediately. There's no loading once it's there, right? We're getting immediately loaded out the first set of HTML. So this is what I was talking about. You're going to get that first state loaded immediately for that user, and then it's going to start making all the AJAX calls, right? Then it's going to start loading all that kind of stuff. Does it make sense? It's a lot of like machinery to plug together, but it's pretty cool, I think. It's really, always really hard to tell because we're doing it like all local development, right? And so there's no round trip. Our round trip is just electrons in our laptop, right? But this can make a big difference when if someone
and electrons in a laptop there, yeah.
is coming from like India to US East, right? That can make a big difference.
Is there a way that you can simulate that?
Yeah, I mean,
Your server's in a Docker container or something?
certainly you can do that. You can certainly slow it down that way. The easiest way always is if I go to like the network here, you can always choose a throttling here, and you can put yourself on like, oh, I'm on Firefox again. But you can put yourself on like good 3 or regular 3G, right? And I refresh. Now Firefox is going to make it seem like everything's going a lot slower. So I use that quite a bit. And if you don't use it on you should look at your app on various different speeds. You should also look at your analytics to see what devices and what speeds people are accessing your computer on.
That was pretty wild, bro. That was pretty wild because with this node string with express, which is part of the bare bone of I think that must be used is some or define some sort of server there. Exactly the server here, for example, like this. He must have defined that already. So you can say, hey, okay, some surgery, tailwind, CSS, server-side rendering code splitting. That's where you say it's like, hey, this render apps, which is from here, okay, this actually expose some methods here. That's why interesting, the output here is exporting. Okay, the output here is exporting. The output here of this server app.js is saying, hey, we are going to actually load this again, but this is on server side rendering. That was quite interesting, by the way. That was quite interesting, by the way, a NoString would express. So the idea here is that exactly. So the idea here is that exactly. So the idea here is that by letting the React know how to render your app for the client and for the server, okay, using Vite or any other model bundler, okay, with Express we are now going to serve such content as available. We're gonna sum such content to the client as soon as available. Okay, as soon as available. So we're gonna exactly as soon as available. And this is something that you can. And this is something that frameworks like Next or Nox is doing behind the scenes. And that makes a lot of sense. That's the entire reason of all of this. There's no need to actually understand each one of the independent things that it's doing. But again, streams is a data structure in Node.js that is saying, hey, the response here. So I want to connect is the response from. I want to connect is the response with whatever is given the React. Holy moly. But the idea here of this NodeStream would express is to say, hey, once you are now build the client bundle as well as the server bundle, and on the server, let me actually now pipe that or connect that to serve the content for you, to serve the content, to serve the app content. And another question is like, okay, then how you do this client-side rendering, okay, or server-side fetching.
So then you really know who to target. Who wants to do something silly and dumb with server-side rendering? Okay. Do not do this today. This is kind of a preview of what's coming, but it was so easy to do that I think it's pretty compelling. What if you want to show everyone the pets right away? You want to load the first load with everything there. That would be pretty cool, right? That the user is immediately getting the first set of pets right away. The way that you would do that correctly today is basically you would have your server. So here in server.js, basically like write some method that calls that API
Mm-hmm.
every 5 minutes and cache the result, and then go into your React app and make it so like, hey, if there's a cached version available somewhere in the HTML or something like that, use that first, otherwise make that request. You can also give React Query like a cached initial data. That's what you would do there, right? And that would work today really well. But let's do this with like basically no code. So we're gonna mess with suspense. You're not supposed to use suspense this way yet. The React team was very adamant that I should probably not show you this, and I do not care. They don't pay me, so we're gonna do cool stuff together. All right. If you're on node 18, you don't have to do this part. If you are on anything underneath, if you're on node 16, you must do this. If you're on node 14, this will just not work. So if you're on 16, you must do this. If you're on node 18, you don't have to do this part. If you are on anything underneath, if you're on node 16, you must do this. If you're on node 14, this will just not work. So if you're on node 16 like me, put node here and then put -- experimental this. If you're on node 14, this will just not work. So if you're on node 16 like me, put node here and then put -- experimental fetch, like that. Okay?
Okay, this is to actually
Then I need you to pop into
this
app.jsx.
feature that is now available in Node. That is
And here
fetch.
where you have queries, stale time, and cache time, we're going to turn on React queries suspense : true. This is an experimental feature built into React query that allows it to interact with suspense as well. If you remember, we have suspense right here, right? So basically what React query is going to do is like, hey, if you're loading something, throw it into suspense mode, right? Which they don't want you doing yet, but it is possible. Because all it does is throw a promise, and suspense just catches promises, which is a weird API, but it's how they chose to do it. Okay. Build your client again. Now if I refresh the page, server layer, and then serving them complete HTML, and you'll see it is now everything. So if you look at the source here, you'll see here that we're getting Luna is coming up in here, Havanese, Seattle, Bunahaben, they're all coming up here in the results. It's actually going in the browser or in our server, and it's calling fetch to the API on the server layer and then serving them complete HTML with all the results, with the breed lists, all that kind of stuff, just pre-hydrated.
God damn.
Imagine if you were serving requests to Mars right now. You would definitely want to do something like this because round trips are so expensive to Mars, right?
Mm-hmm.
So this could be something really useful if you need something that's like, you want to send it all in one payload, just right away. This would be a cool way to do it. Calling fetch from your server on every request, probably a bad idea. Probably don't want to do that, right?
Exactly.
That's why I was saying here in your node code, you would much rather make all those requests in like some sort of like local cached way of doing it and just hold that in there and then hydrate it on every request, right? Then you're not making, if you're getting 5,000 requests a second, you're not making 5,000 fetch requests. All the same, it's pretty entertaining that I was able to do this with just a couple of lines of code, right? So that style of doing data loading with suspense is coming, trademark coming, right? It's been coming for like 5 years at this point. They are getting closer. You can see now that it actually does work, but don't hold your breath, but it is coming. Basically what they're saying is that they don't like their throwing promises API, and they're promising to change it. So they don't want people relying on it quite yet.
Okay, server-side fetching. All right. The server-side fetching, which is here, is using back in the 2021 the experimental flag of fetch API, but they don't recommend the React community to use that now. Okay. All right. Server-side rendering and node stream and server-side fetching. Server-side fetching, bro. Server-side fetching in Next. Building your app and data fetching for that. Get server-side props. Data fetching, catching, and revalidating. Exactly. Catching data and this one. But this is for GraphQL and use server convention. Okay, this is the people on there. Interesting.
Some initial state. This initial state is just a message. Server actions for our applications, denoted by the use server directive at the top of all of the server actions for our applications, denoted by the.
Holy moly. Okay. All right. That's pretty well. So yeah. All right. Cool. Interesting. Interesting. Very, very interesting. Yep. Totally. Okay. Well, that'll be all for this video. Take care. Bye bye.